Hello there guys, welcome back to another epic inexorable maths video. In this video we're doing another integration by parts video, believe it or not. We're integrating the natural log of x. So about 2 videos ago I said that you could use integration by parts to integrate functions that are not products, even though some people like to think of integration by parts as kind of like the reverse product rule. I mean, it's 2 things times together, right? One of them is u, one of them is dv dx. They times together, you have a formula. But what about the integral of the natural log of x? It's just one function. It's one thing on its own. The natural log of x is one thing. But I'm telling you, and it's not a joke, that you do need to use integration by parts to do this. And if you've not seen this kind of thing before, I think it's quite cool. So let's just dive straight into exactly how we do this. Let's not waste any time, guys. So what we're going to do, believe it or not, is we're going to let u equal the natural log of x. That's maybe the obvious part. But we're going to let dv dx equal the number 1. Yeah. So we're just pretending that the natural log of x, or pretending, but we're thinking about the natural log of x as 1 multiplied by the natural log of x, which is true, it is. But can you imagine doing that with like the product rule for differentiation? If I said, what's the derivative of x squared? You wouldn't say, aha, let u equal 1, let v equal x squared. Use the product rule. You wouldn't do that, no. But actually for integration, because integration is a little bit more weird, yes, we do these weird things. So one of the functions, we just make it up, we just say it's the number 1, which is fine. Let's just see what happens when we do this. And by the way, guys, you might say, oh, wait, how do you know which way around it is? Here's the thing. Du dx is 1 over x, right? Because it's the natural log. It's 1 over x. And v is the number, or is the function x. If we had labeled these the other way around, what would the problem be? Pause the video, think about it. Why can I not label these the other way around? And don't even worry about order of priority or anything like that. Just think about, why can I not swap the orders? Pause the video, think about it maybe. The reason is because if we had let dv dx be ln x, what would v be? Because we would need to integrate it, and that's the entire question. The question is, what is the integral of the natural log of x? You can't let dv dx be ln x, even ignoring that order of priority, even ignoring that, you just don't know what it integrates to yet. And if you did know, you might, well, I already know. Well, you can't use it because you're trying to prove, you're trying to show what the natural log of x integrates to, so you can't use that in the working out. That's basically the reason. It has to be this way around. Just logically speaking, it has to be this way around. Anyway, we then go into the integration by parts formula, and we have that the integral of the natural log of x is u times v, so the natural log of x times x. I'm going to write that as x ln x. Okay, minus the integral of 1 over x times x. What is 1 over x times x? It's pretty much just the number 1, or it's exactly the number 1. 1 over x times x is the number 1. So now we just have x ln x. And what is the integral of the number 1, guys? The integral of the number 1 is just x. So minus x, and what's the last thing we need to do? We need to add c, plus c. And that's the answer. The integral of the natural log of x is x ln x minus x plus c. The more you know. And guys, yep, you do need to use integration by parts. It's quite cool, right? So this happens fairly frequently when you need to integrate a function that's kind of like, I guess it could be the inverse, like ln x is the inverse of e to the x. This is also how you integrate arcsine and arctan as well. We've already seen how to differentiate those in my differentiation playlist. But if you want to integrate them, you need to use integration by parts again. So it's kind of like functions that you know how to differentiate but not integrate. Sometimes this will work. Not always, but sometimes it will work. And we'll do those videos in the future. But for now, thank you guys so much for watching. I highly appreciate it. And I'll see you in the next video.